All right, ladies and gentlemen, this is Mr. Anderson for Kellogg Community College with part 7 of our long series covering each page of the final exam review. Now what we're going to do here is we're in Chapter 5, and Chapter 5 deals with a little bit of factoring. What's going to be important about this is we're going to just quickly review some of the concepts of factoring. Well, the biggest concept is that you always look to factor out a common term. And in this problem with a to the 6th, a to the 5th, and negative 6a to the 4th, a common factor would be a to the 4th. So this would leave us inside here with a squared plus a minus 6. Now, what this leaves us with an easy trinomial, and what we will think about are all the factors of negative 6, and then which basically pair adds up to make the positive 1. So what we have here for negative 6 is 1 and negative 6, negative 1 and 6, negative 2 and 3, and 2 and negative 3. So which combination makes a positive 1 in the middle? Well, the one that makes the positive 1 in the middle is this combo. So this is going to be a to the 4th times the quantity of a minus 2, and then a plus 3. Because if I FOILed this out, I would get a squared plus 3a minus 2a, which would give me the 1a. I know that looks a little weird now. And then if I multiply the negative 2 and the 3, it gives me the negative 6. So the factored form is a to the 4th times the quantity of a minus 2 and a minus 3. In problem number 4, we are also going to now do difference of squares, but before we do, we should try to see if we can factor anything out. And we can factor out a 4 here. So this would leave me with m to the 4th minus 25. Now this is still a difference of squares because each of these numbers we can take the square root of them. So this makes the square root of m to the 4th is m squared. The square root of 25 is 5. So the difference of squares pattern is m squared plus 5, m squared minus 5. And what makes this problem just a little bit stranger is that we didn't have a 2 here, we had a 4. So this problem is factored as 4 times the quantity of m squared plus 5 and m squared minus 5. If this wasn't a 5 and it was, let's say it was a 4, we could actually keep going in like m plus 2, m minus 2. So always look to see where you have a squared minus a number to see that it isn't a difference of squares pattern. Alright, now finally, as promised, there is a SOPs problem, and in problem 25 here, a SOPs problem deals with the sum or the difference of cubes. Now what we'll do here is we are going to see if this is a perfect cube. So take the cubic root of 343, and if you do so you get an answer of 7. So my a is going to be equal to 7x, because that is the cubic root of 343x cubed. Now my b is going to be the cubic root of 27y cubed, which is going to be 3y. Because the cubic root of 27 is 3. Now these first two terms, this a and b, that makes my first binomial in my answer, 7 plus 3y. Now the actual SOPs part, or the reason why I call it SOPs, is because it's the square of the first term, so it's 7x quantity squared. It's the opposite product, so it's negative the 7x times the 3y. And then it's the square of the last term, or 3y quantity squared. So what this means is that we have 49y squared, and then we have the opposite product of 7, 3xy is going to be negative 21xy, and then we have the square of 3y, so this is going to be 9y squared. That, my friends, is the complete factorization of a sum of a trinomial problem here. So the sum of a cubic or the difference of a cubic can be done with the SOPs, or as some people call it, a b-SOPs. Alright, now finally we're going to do a problem here from chapter 6, and what we're going to do is we're going to just simplify this problem as much as we can by making it into a smaller fraction, or using the laws of factoring we can actually make the problem look a little easier. So we're going to see if we can factor anything out of the top and bottom. The 3 is factorable by the top is factorable by 3 because we can factor out a 3 and have x plus 7. The denominator is factorable by x, which leaves me with x plus 7. Now, before we do any simplification here, we should note that we have excluded values, which means that if my x is equal to 0 or my x is equal to negative 7, what we have here is a division of 0 error, because the denominator, that x squared plus 7x, cannot be equal to 0. So if I solved just the denominator for not equal to 0, I'd have x and x plus 7x is not equal to 0. I'd have then x is not equal to 0. And I would also have, whoops, I shouldn't have an x there, thank you. Then I should have x plus 7 is not equal to 0. So if I move the 7 over, this is x is equal to not equal to negative 7. So I have two excluded values. So in my answer here, I'm going to have to put down that x cannot be equal to 0 or x cannot be equal to negative 7. If I really want to be nice, I'll put that in set notation so you can see that x can be anything else real. But now we're going to get down to the meat of the problem, which is actually simplifying it. Well, you can see that this binomial is the same as the other binomial, so this gives me the answer that f of x is equal to 3 over x. And this brings up a good point. You can only simplify binomials or some part of the binomial if they're an exact match as the others. So this is not legal. You cannot just cross out the 7s there. You can't do that because this is part of a binomial, and you can't cross out part of a binomial if it matches just a monomial in the other part of the denominator. This is another mistake I see every once in a while. I'll see x plus 1 and x minus 2. Oh, sure, cross off the x's, so it's negative 1/2. No, you can't do that either. This is a big mistake, and so is this. Please don't do that. 3x plus 4 over x. You can't cross out the x's. You can't do that either. You can only cross out a binomial if it part of like this binomial if it matches another binomial. So please don't fall into that mistake if it shows up somewhere else on your final exam or in any other class for that matter. All right, well, thank you very much for watching video number 7.